Hello and welcome to this first video about GIS data types and formats. First of all, I would like to tell you what is a GIS. A geographic information system can be defined as a set of hardware, software, data, methods, and people. So it's not only the software or the hardware. And its aim consists in the management, analysis, and display of geographically referenced information. And please consider that each entity of land has a special information. Where is a field? Where is a school? How long is a road? And so on. And GIS allows us to visualize, understand, and discover the special relationships between geodata in form as maps, charts, reports, and more. And what can be done with the GIS? With the GIS, we can map the position, the quantities of things, let's say population, for example, the densities. So how density is a population, and what happens inside a specific area, what is nearby within a user-defined distance. Let's say what are the villages within a distance of 100 meters from the main river, and the evolution and change of phenomena, let's say land cover change. And GIS is integrates geographic information and not only in a decision supporting system. So please remember that GIS is a tool, and this system represents a real world through data structured in layers. We will speak about layers. Each layer has some informations and organizes data for fast and effective analysis. And as well, GIS provides tools for planning and management, so we can analyze resources such as water, roads, coastlines, urban areas, vegetation, and cadastre, and we can solve problems such as fires, pollution, forestry, agriculture, tourism, and health. So how does a GIS work? Then we'll see in details with the next videos. And GIS stores geographic information in separate layers, let's say separate informations. And GIS collects information, stores, they can query, then we analyze information and we show results and we produce outputs such as map or WebGIS. To do this, we use two main spatial data models, and spatial data are alphanumeric information linked to a specific location. So there is the geographic aspect, let's say the position, the point, and the related information. And alphanumeric information is displayed on screen and they are related to a location of features in the real world. And this is called data model. So let's say we have points and the information of each point, as well as road, polygons, and satellite images, for example. And we have two main data models, vector model and raster model, we will see in detail. And spatial information is displayed in a GIS using spatial layers. So this is different layers, and a layer could be based on raster or vector data model. So let's see vector data model. It's based on geometry type such as point, polyline, line, and polygon. So we see here how we can represent, let's say, houses or villages, rivers or roads, and let's say fields. And associated to graphical information, there is a table that stores alphanumeric information related with each of the geographical objects. And each row of the table corresponds to one and only one spatial object. So we see an example. We can have the field as polygon, we can have the roads, we can have rivers, we can have single trees. So it depends also on the scale how you can represent the features in the real world. And the table can be browsed, the attributes of the table can be browsed after we have been stored through different languages, such for example SQL, and usually we utilize a user-friendly interface such as this in GVSig. Moreover, what is the most important, most common vector format? It's called shapefile. It is one set of files containing at least 3 files that must be named and stored in the same directory. The 3 files belonging to the same shapefile. And these are the .shp format that stores vector info, .dbf that stores attributes of the vector layer, and shx that stores partial indexes. We have then the raster data model that is based on a grid of cells called pixel, and their representation of the real world. And a raster image or a raster layer stores numerical value for each pixel. So raster data model is used mainly to represent continued features such as elevation, temperature, aerial or satellite images, let's say information that does not change drastically, let's say does not change like a land use. So it's not field or urban, but let's say the temperature can slowly decrease or increase along the world. So we see this is the representation of raster data model. We have grid and cell, let's say data structure, whereas the geographic area is divided into cells identified by rows and columns, so X and Y. And you see that we identify the grid extent, so the number of rows and columns, for example 8 times 8, the grid resolution, so it's the cell size, it is the dimension, and the georeferencing information. So this is the origin 0, 0, let's say, of the raster data model. So basically, as I told you, a raster pixel attribute is generally a single numeric value called digital number. In this case, it is elevation. So we have for each pixel, we have a digital number showing the elevation. Then the raster formats are several formats as well as the vector layer. And so we can have the TIFF, the JOTIFF, JPEG, ECW, RAS, and grid, that is a format typical of Esri software. So we see how we can represent the same object in a vector or in a raster data model. So we see here the houses, the lines, let's say pipelines or electrical lines, and some areas such as forest. Then we have as well vector data are represented, as I told you, such as discrete data, or for example trees, wells, roads, railways, lakes, while raster data can represent by continuous data such as soil humidity, precipitation, elevation, and slope. Well, I hope you enjoyed this first video and on GIS data types and formats, and next one will be about the spatial reference systems. Keep in touch.